In many urban floods, the water that enters the house does not come from outside, it comes from below. During extreme storms, public sewer systems reach their hydraulic limit. When this happens, the flow direction can reverse. Wastewater is pushed back through the same pipes that normally protect the building. Floor drains begin to overflow. Toilets start to rise. Utility rooms become flood zones. This is backflow, and without protection, it is unavoidable. Urban sewer networks are designed for a specific peak flow. When stormwater and wastewater share the same pipe, extreme rainfall fills the system rapidly. Once the pipe is completely full, it no longer behaves as a gravity system. It becomes pressurized. And pressurized water moves toward the lowest available opening. In many homes, that point is the basement drainage connection. Any plumbing fixture located below the street sewer level is at risk. This includes basement floor drains, washing machines, utility sinks, showers, and toilets. These fixtures are physically lower than the public network. When backflow occurs, gravity works against the building. Water is pushed inside instead of flowing out. Flood protection begins with understanding this elevation relationship. The most common protection device is the backflow valve. Under normal conditions, it allows wastewater to leave the building freely. When flow reverses, an internal flap or gate closes automatically. This creates a physical barrier between the public sewer and the house. Modern systems use dual flap mechanisms, self-cleaning channels, inspection chambers for maintenance because reliability is critical. If the valve fails, the basement floods. Backflow valves protect against reverse flow, but they also temporarily block normal drainage during a storm. This means basement fixtures cannot be used while the valve is closed. The full solution is a lifting station. Wastewater from the basement is collected in a sealed tank and pumped to a discharge point above the backflow level. This makes the basement hydraulically independent from the sewer surcharge. Even during extreme rainfall, all fixtures remain operational. Backflow is not the only flood pathway. Surface water can enter through basement windows, external access stairs, ventilation openings. These points must be elevated, sealed, or protected with local drainage systems, because a single unprotected opening can bypass the entire backflow protection strategy. Flood resilience requires a complete envelope approach. New systems add a predictive layer to backflow protection. Sensors monitor the water level inside the sewer connection. When surcharge conditions begin to develop, the system sends an early warning. Automatic responses can include closing protective valves, activating lifting stations, alerting occupants the building no longer reacts to flooding. It anticipates it. Many homes were built without backflow protection. But retrofitting is possible. Compact inspection chambers, inline backflow valves, localized lifting units. These solutions require limited space and can be installed without rebuilding the entire drainage system. This makes basement flood protection one of the most impactful upgrades for climate resilience. The most dangerous floods are the ones you never see coming from below.